Hi guys, my name is Vinay Jain and today we're going to be discussing depth first search algorithm, DFS algorithm using stacks but for a general tree. So previously we discussed DFS algorithm for binary tree. Now we're going to do for general tree using stacks. What is a general tree? Binary tree is something that in which every node in the tree has maximum 2 children. But in general tree you can have 0 children, 1 children, 2 children or more than 2 children. For example, if look at the diagram on the left hand side. So in node A, if we consider node A, how many children does it have? It has B and C, right? So 2 children. However, if you look at node B, so node B has how many children? This is 1 children, this is one, and this is the other one. So total 3 children, which is more than two. Similarly, if we look at node C, just a moment. So if we look at node C has this is 1 children, A child, B child, D child, and F child. So it has 4 children. So how does the depth first search algorithm work if we have a general tree and we want to find something in that? So let's say our target is D. So I'm writing it here. Target is G. The G node. This is our target. So how do we work with this using depth first search algorithm? The idea is the same. We'll be using stacks for our purpose, and we'll have pop node and visited set. Also, I would like to point out this video is also aimed at, other than how the depth first search algorithm works for general tree, this video is also aimed at understanding why do we need visited set, what is the purpose of it, why do we use it. So this video will help explain that. So before proceeding, let's notice that A has children nodes as B and C. I'm writing it in alphabetic order. B has A, C, D, E as its child nodes. C has A, B, D, and F as child nodes. B has B, C, and E as child nodes. E has D and G as child nodes. F has C and G as child nodes. And G has E and F as child nodes. This is from the tree representation that I've shown you on the left hand side. Sorry, my bad. So now that we have this information, let's proceed with our algorithm. So as usual, we'll push the root node into the stack and add this to our visited set, signifying that we have visited this set. Now we pop the topmost element in the stack, which is node A. So we pop this, assign it to pop node. So now for binary tree, what was depth first search algorithm doing? It was checking whether it's whether the left child or the right child is in the tree or not, and we push that onto the stack, right? But in depth first for general tree, we'll be checking for all its child nodes. So let's say we're dealing with node A, right? So for node A's all child nodes, so every child node that it has, we'll check for them whether they are in this visited set or not, basically suggesting whether they have been visited previously or not. So node A's child is B and C. So is B, let's consider B first. Has B been explored earlier? No, it hasn't, right? So these are the child nodes of A. So has this been explored before? No. So we add this to our visited set as well as we push it onto the stack. Next, we check the other child node, which is node C. Has this been visited before? No. So we add this to our visited set and add this to our stack as well. Now that we're done iterating over all the child nodes of node A, we then pop the topmost element in the stack, which is node C. So we pop this element, assign it to pop node. Now we're working with node C. Just before we proceeding, note that we have now traversed in this direction. Since from node A, we move to node C. That is what we're working on right now. So C, what are the child nodes of C? C has child nodes as depicted here, A, B, D, F. So we check one by one whether A, B, this is B, this is D and F. Have all of these been visited before? So A has been visited before, so we're not going to work with that. B has been visited before as it's in the visited set, so we're not going to work with that. D has never been explored before. So we add D to the set, visited set, and add it to the stack as well, on top of the stack. We check F. Has F been visited before? No. So we add F to the visited set and add to the stack as well. So now that we're done working with all the child nodes of C, we then pop the topmost element in the stack, which is F, and assign it to pop node. Now we check what are the child nodes of node F. So node F is here, and what are the child nodes of it? C, G. So it has two child nodes, C and G. So we first check for node C. Has this been explored before? Yes, because it is in the visited set here. So we don't do anything. Next we check the other child node, G. Has G been visited before? It's not in the visited set, therefore not visited before. So we add this to our visited set and add this to our stack as well. Now that we've done this, we pop now the topmost element in the stack, which is this node. Sorry, my bad. We pop this element and assign it to pop node. Now we check, is node G the target that we're looking for? It is it, right? So that means we have found a match, and therefore we return true, signifying that we have found the node that we were looking for in the tree. So this is the algorithm for a depth first search using stacks for a general tree. Notice that we first visited node A and then we went to node C. Then from there we went to node F and then node G. This is how we found whether G exists or not. This is the path that we took. We could have taken some other path as well, maybe somewhat like this, but this is how it panned out given how we arranged our algorithm. So what is the algorithm for this? How do you actually work with this? So this is the pseudocode for that. So this is the algorithm for DFS using stacks for general tree. So what do? You create an empty stack and visited set. You add the root of the tree to the stack and a visited set. This gives a heads up to the algorithm to start working with the root node of the tree. And this is where you actually begin your algorithm. And step 3. So what do you do first? You pop the node at the topmost node in this stack. So whatever is at the top of the stack, you pop it and assign it to pop node. Then you check whether the pop node's value is equal to target or not. If that pop node is what you're actually looking for or not. If it is, then you return true. If not, then you proceed ahead. And for all child nodes of pop node, you'll be having a list of the child nodes of every node, and whatever the child node of the pop node is, for all of them, you one by one traverse and check whether those child nodes have been added to the stack or not, whether they have been visited previously or not. So you get those child nodes and check if that child node is present in the visited set or not. If it is not present, then you push that child node onto the stack. Otherwise, you update the visited set. And otherwise, or either ways, you have to update the visited set, signifying that this child node has now been worked with. You keep on iterating till the stack is not empty. And once the stack is empty and you still haven't encountered this condition, that means the node that you're looking for was never in the tree, and therefore at the end of the iteration loop, you return false, signifying that the node that you were looking for is still not found, and thus it is not present in the tree. So this is the algorithm for DFS using stacks for general tree. Note that this part for binary tree was essentially before. For binary tree, it was push left and right child onto the stack for binary tree. This has now been replaced by for all child nodes of pop node. So you're doing the exact same operation, but instead of working only for left and right child nodes, you're working for all child nodes. If they are in the visited set already, that means you have worked with them before and therefore you do not need to work again. If they are not, then push them onto the stack so that you can work with them later. I hope you guys enjoyed this video. I hope this video helped clear your concepts.